Hello, everyone. Thanks for tuning in. Excited to be here today and a lot of fantastic presentations. My name is Jessica Meck. I co-coordinate turtle ecology projects here at the Smithsonian Conservation Biology Institute. And today I'm going to be talking to you about our current efforts and process in evaluating the distribution of the spotted turtle here in Virginia and hopefully North Carolina. So to give you a little bit of background about the spotted turtle, or Clemmys guttata, it's a small semi-aquatic freshwater turtle found in the eastern United States. It's primarily distributed from Maine to Florida along the coast. It gets its name from its beautiful yellow spotted pattern on its carapace. Adults are only about 4.5 inches in length. It is considered endangered by the IUCN, and it's a species of greatest conservation need in all 21 states that it occurs. It's also recently been pegged as a candidate for federal listing on the Endangered Species Act due to declining populations throughout its distribution. Its major threat is habitat loss and fragmentation. There's a long history of draining and ditching wetlands and, of course, increased pressure from development. It's been cited that the United States has lost well over 50% of its wetlands since colonial times and European settlement. The second threat is road mortality. There are some populations where dozens of individuals can be killed in one day if conditions are right in the spring and early summer when females are nesting. This is a problem because they are long-lived species. They can live well over 60 years of age, and they don't reach sexual maturity until 10 to 12 years. So they reproduce very slowly. Collection for the pet trade is also a major threat, like many freshwater turtles across the world. They pop up in confiscations. Their popularity does fluctuate in the markets, but it continues to be a threat for individual populations. Climate change is another major threat. Because they are a coastal living species, sea level rise threatens to contract their range further. But this hasn't always been the case. They were once cited as the most common species in Massachusetts by Storr 1840, and throughout New England in general. And we believe this to be the case in other states, such as here in Virginia, especially in the mid-Atlantic coastal plains, Delmarva Peninsula, and Barrier Islands. But they are also found in other regions, such as the Piedmont, and Mitchell and Ray in 1999 even cited that range needs better defined. If you're unfamiliar with our ecoregions here, here's a quick map. It consists primarily of the Ridge and Valley, the Blue Ridge, Piedmont, and then your Southeastern Plains and Middle Atlantic coastal plain. And so we do have a few scattered records in the Piedmont and Blue Ridge and Ridge and Valley. We continue to collect records. In 2017, we added 3 new locations in the Piedmont and Lower Blue Ridge. And just as of June of this year, we had a new county record in the Ridge and Valley. So we have approximately 216 sightings and records to date. In Virginia, there hasn't been a lot of published studies. I know of one PhD project and one master's project looked at it, but most of the information that we have available now is from the late Joe Mitchell, from his papers and books summarizing the records he had currently and their distribution. Him and Kurt Bielman in 2007 did conduct an inventory of known populations and other sites with potential habitat in 25 to 2007. Their focal area, however, is limited to southeastern Virginia due to the increasing pressure from development. And unfortunately, something very discouraging is they found one new site, but was later destroyed for housing development within a year. And this is a picture of that site. And as they noted in the report, unfortunately, the turtles were buried alive in these agricultural ditches. In North Carolina, there's even less information available. Palmer and Broswell in 1995 summarized the records in their Reptiles in North Carolina book. There was a recent publication in 2016 by O'Brien that looked at habitat use and selection in a reconfigured forested landscape, a really great paper. And North Carolina has a little bit more records than Virginia at 297. So luckily, right now, there's a regional status assessment occurring. It was awarded in 2017 by the host state Virginia Department of Inland Fisheries. It's a U.S. Fish and Wildlife Service Competitive State Wildlife Grant, or COMPSWIG, and with the goal to help better inform the Fish and Wildlife Service on their listing decision in 2023. And also states wanted increased coordination for the conservation of the species and to maintain populations of spotted turtles and their associated habitats. The grant was broken down into 3 projects. The first was quantify distributional trends and baselines, assess population status at multiple scales, and manage habitat and populations. So for the second project, part of that consisted of creating a standardized monitoring protocol. So all of the states, most states from Maine to Florida participated, and able to collect standardized abundance and demographic information, primarily through trapping assessment and visual encounter surveys. And these are just a few examples of the data sheets that we use. And so far here in Virginia, we've been able to sample 15 different sites, over 2,200 trap nights, and over 300 captures in 2 seasons. Unfortunately, due to COVID-19, we were slated to sample more sites this year, but it's been canceled. North Carolina, unfortunately, was unable to participate in the comp SWIG, but we, as CVI and partners, were awarded additional funds to sample this year to be part of the regional status assessment. But again, that was delayed until next spring, where we're hoping to at least sample 5 or 6 different sites. In addition to our standardized monitoring data collection, there were 2 fantastic complementary models created. The first was through the project 1 of the comp SWIG by our colleagues at American Turtle Observatory. They created a species distribution model that can be considered a predictive relative probability of occurrence. So they use an ensemble model approach at multiple spatial scales with various topographic, climate, and land cover variables. This model is very dependent on available spatially validated occurrence data, so those about 190 records that I mentioned. And so Virginia was a challenging state to model, it was noted, primarily because most of our data is concentrated in the Southeast, and not all of the records could even be used because they're not spatially accurate enough. The second model that we have available by our colleagues at University of Massachusetts, the Landscape Ecology Lab, they have an awesome Designing Sustainable Landscapes project. They modeled for 13 states to date. They used a suite of representative species to model and guide habitat conservation efforts. And so it's a landscape suitability model. So it represents where spotted turtles could occur based on habitat, climate, and prevalence. Now this model relies heavily on expert opinion, and it was noted that it is New England biased due to the experts that were able to partake in this. And it does focus on connected intact landscapes and large complex wetlands. And this is a problem because one, the habitats are very different from here in New England, and we probably have sustainable populations in larger fragmented areas that are actually dominated by ditches and vernal pools. However, I want to show you what these 2 models look like in comparison. So this is an area in the Ridge and Valley region where we have records. On the left, you have the comp SWIG probability of occurrence model, and on the right, you have this landscape suitability model. It's scaled minimum to maximum. So green represents low probability of occurrence or landscape suitability, red representing maximum values for probability of occurrence and landscape suitability. So you can see in the Ridge and Valley, these models aren't very complementary to each other. The comp SWIG model does seem to indicate there are areas of high probability of occurrence. In the Blue Ridge, again, it's not very complementary to each other. Both have fairly low probability of occurrence and suitability. But if you move into the Piedmont, there's this very stark difference with the comp SWIG saying the landscape has a high probability of occurrence, where the UMass is saying the landscape is not very suitable. However, if you move into the Southeastern Plains, where most of our data is, they become much more complementary, high probability of occurrence and landscape suitability, as well as the Middle Atlantic coastal plain. And so how do the models help us? If we don't, no model is perfect. They're only as good as the data you can put into them, and we're missing a lot of areas here in Virginia. But they're just one component of a suite of tools we can use to build a conservation area network, and this is part of Project 3. And this has been done for the Blandings turtle and the wood turtle here in the Northeast. These models serve as just one piece of a very complex modeling process to rank sites for conservation efforts. And they can also guide prioritization decisions for sampling new areas. Like I said, we can go to where we think the model's not performing well and collect data in order to better train those models and future models. They also can help us evaluate future land use change through scenario planning. So we have a lot of long-term objectives that we want to do to really start bolstering our efforts in Virginia, our conservation efforts for the spotted turtle. The first is the strategic sampling in the Piedmont Blue Ridge Ridge Valley, because we do believe the spotted turtle is more widely distributed throughout the state, but in lower abundance than what we believe currently. We also want to start prioritizing the monitoring efforts in the coastal plains, where we know historically populations of spotted turtles have been abundant. And we also want to start looking at monitoring the barrier island populations to start assessing their viability due to the threat of climate change and sea level rise. We also want to develop a working methodology for eDNA sampling. We've been successful with this for the wood turtle here in Virginia. And because spotted turtles live in such difficult dynamic habitats, using eDNA would allow us to more rapidly evaluate their distribution and be more cost effective than doing just strictly visual encounter surveys and trapping assessments. And finally, using the results from the regional status assessment and the conservation plan that will come from that, we'll develop an adaptive state level conservation plan with a goal to ensure sustainable evolutionary significant sites remain on the landscape, and of course their associated habitats, because many species rely on spotted turtle habitats. I'd like to thank the many partners that make this work possible, all of the state, federal, nonprofits. Patrick Roberts and Brad Compton led the efforts on the models, and the many people that have provided us with technical assistance, advice, and the many students and interns that have helped us conduct the sampling. And with that, I'd be happy to answer any questions if there's time left. One question: are there any plans to create a model better suited for the southern United States using Virginia and other experts? Not that I'm aware of, unfortunately. Next question is, how can we stop wetlands and other wildlife habitat from being turned into development? That's a great question. I think education is a big key in communities. So if communities have wetlands nearby and they care about them, we can get more people involved to make more noise to preserve those wetlands. Next question is, how can we get involved in identifying monitoring populations here in Virginia? Another great question. We can, identifying. That's a great question. I think sending data, especially to Virginia Department of Game and Fisheries, you can report any species, any turtle, any reptile, amphibian, mammal, through the reporting system. So if you go to their website, you can do that. Or you can send it to us here at Smithsonian Conservation Biology Institute. We get people letting us know they found a turtle on the road, and we keep that in our database. And I think that's it. Thank you, everyone.